Okay, crude oil, hydrocarbons and stuff. Here we go. Crude oil can be distilled into fractions. Yes, it can. Which of these mixtures shows formulae of substances that could be in the gaseous fraction? Okay. Well, looking at these four choices, each one has a 2-carbon molecule, a 3-carbon molecule and a 4-carbon molecule. Okay? So how do we distinguish them? Which is the correct answer? Which one of these is going to be likely to be in a distilled fraction of crude oil? Well, that's got an oxygen in it. There's a bromine there. There's a bromine there and an oxygen there. Okay? These are not hydrocarbons. Hydrocarbons are made purely of hydrogen and carbon. So it's going to be C, this one. It's only carbon and hydrogen in C. And so that's the one you're going to find in the fraction of crude oil. Okay. Right, so we've got these three different crude oil wells, A, B and C. We have to state which oil well contains the greatest combined total of diesel oil and fuel oil. A 6-year-old could do this. I don't know why they're asking this. Okay, so we've just got to add these numbers up. It's literally what 6-year-olds do, these sort of numbers. Okay, was it again diesel oil and fuel oil? Okay, so those two, that comes to 46, that's 38. And that's, I better be able to do this because I said a 6-year-old can do it. 33. Okay, so it's well C. Okay, that's the one, the most amount of diesel oil and fuel oil. Okay, right. Which oil well contains the highest percentage of the high boiling point fractions? Right, which are the high boiling point fractions? High boiling point means you've got to heat it to a higher temperature in order to get it to turn into a gas. It's the ones that are difficult to get to boil. So that means the long chain stuff, and that's these sort of things, bitumen and fuel oil. And as you go up this list here, the carbon chains get shorter, so the gases are short, at like 2 carbons, 3 carbons, 4 carbons, and then petrol is sort of about the sort of 5 to 8, I think. I'll have to check that. But it's around the sort of 5 to 8 or 9 carbon length, then it gets longer and longer here. So, right, we've got to add up some numbers again. The highest percentage of the high boiling point fractions. So let's add these numbers up and see. So that's 31, 40, 55, is that right? Who cares? 70, 84. Right, so it's A. Okay, what a stupid question. Next, this thing here. Decane is cracked with this experimental setup here. Okay, and we have to explain how ethene is produced for 3 marks. Okay, so what's cracking? Cracking is when you pass a hydrocarbon in gaseous form over a hot catalyst and a chemical reaction takes place as it comes into contact with the catalyst, and one of those products, well, it breaks it down into shorter chains or smaller molecules, and ethene is also produced. It's one of the products, one of the broken down molecules. One of the molecules that is a result of breaking down the, well, in this case, decane. Okay, so we've got to get 3 marks. Explain how ethene is produced? Well, let's start over here. We have the decane being heated. The heat is important, okay? So the first thing is the heat turns the decane into a gas. Okay? It has to be a gas, that's important. Next, the gaseous decane passes through the porous pot. Gas goes through the porous pot. Don't say it passes over it, okay? You won't get the marks. You have to say that it passes through it and it comes into contact with it. So, and it comes into contact with the catalyst, which is the porous pot in this case, okay? You have to point out it comes into contact with it, otherwise a chemical reaction can't happen, right? It's a catalyst, it has to touch the decane. If you say it passed over it, then you're implying it's not coming into contact with it. Okay? So next, chemical reaction happens. Chemical reaction happens. And finish off by saying the decane is broken down, okay, into smaller molecules including ethene. Boom, there you go. 3 marks in the bag. Same thing as always, as I keep banging on about, laid out in a nice logical order. And yeah, that will get you 3 marks. So I just want to quickly talk about this porous pot thing. If you've been paying attention in class, you've probably learned that when you taught about cracking, you taught that the catalyst is alumina or silica. Okay? Well, alumina is aluminium oxide and silica is silicon oxide, right? And this porous pot, it's a pot. It's made of clay, which contains oxides of silicon and aluminium. That's why it acts as a catalyst here, okay? So the porous pot is essentially your alumina or your silica catalyst that you've been taught about. Okay, let's move on. Right, let's have a change of colour. Let's go pink. I like pink. Right, so we have C10, H22 goes to, it's broken down into 2 C3 H6s plus something, and we have to say what the something is. Okay, simple. Just count the atoms, right? So we have 10 carbons on the left. How many have we got here? We've got 2 times 3. So we've got 6 carbons, 10 there, so we must have 4 here. So it's going to be C4 something. Okay? Carbons done. Because 4 and 6 makes 10. Same with the hydrogens. We're looking for 22 hydrogens on the right. How many have we got here? 2 times 6 is 12. We're looking for 22, so there must be a further 10 hydrogens there. It's just atom counting. So the answer is C4H10. Good. Which is B on the multiple choice thing. Right. And finally, complete the balanced equation. We have 2 C10H22s plus some O2s goes to some CO2 plus some H2O. Okay, right, how are we going to do this? Well, that's the only term on the right with a carbon in it, okay? There's oxygens there and there, so let's avoid the oxygens at the moment. Let's pick on the one where there's just a carbon, because we know that there's 2 times 10, there are 20 carbons on the left in total. And because that's the only term with carbons, there must be 20 carbons. So that has to be 20, okay? Right. Now, hydrogens. There's 2 times 22. There are 44 hydrogens on the left. There's no hydrogens there. This is the only term with hydrogens in it. We're looking for 44, but it's H2, so it must be 22. Okay? Because 2 times 22 is 44, so now the hydrogens balance. Right, so finally we can put in the number here because we can see how many oxygens we now have on the right. And there we go back to the left here. So the oxygens here, 20 times 2, okay, because it's O2, there's 20 of them, plus, it's only O there, so there's 22 of them. So that's 40 plus 22 is 62. So we need 62 oxygens on the left, therefore. That's an O2, so what's half of 62? It's 31. That's how you do it. Does that make sense? Excellent. Let's just do a quick check. Carbons on the left, 2 times 10 is 20. On the right, 20 carbons, no more. Carbons are correct. Hydrogens, 2 times 22 is 44 on the left. And on there, 22 times 2 is 44. Hydrogens done. Oxygens, 31 times 2 is 62. 20 times 2 is 40, plus 22 times 1 is total of 62. There you go. Done.